Now here we will discuss the example of differentiation using the four-step rule. Now for the general rules for differentiation using the four-step rule, we have the first step is we have to replace the x with x plus delta x and y with y plus delta y, and then we have to simplify it before we will proceed to the second step. Now, on the second step, we have to subtract the original equation from the equation 1. And then we have to simplify it before we will proceed to step number 3. And then in step number 3, we have to divide both sides of the equation by delta x and then simplify. And then finally, the last step, we have to evaluate the limit of the delta y with respect to delta x as delta x approaches to 0, because this is actually equal to the derivative of the y with respect to x for a certain function y is equal to f of x. And as for the first example, we have to differentiate the following example by using the four-step rule, and then we will answer the example number 1. Now, for example number 1, the given is y equal to 3x squared plus 4x plus 12. And using the four-step rule, we have to change the y by y plus delta y and x by x plus delta x. So for the x squared, this is now x plus delta x and then raised to square. And then for the 4x, so x will be replaced by x plus delta x plus 12. And then before we will proceed to step number 2, we have to simplify it first, but then again in this example we can proceed to step number 2 right away, and at the same time simplifying the given operations here. So here we can expand the x plus delta x raised to square, and then we can distribute the 4 by x plus delta x. So what will happen? It becomes like this. We have to transpose the y on the other side, because that is the second step. We have to subtract the derived equation from the original equation, so it becomes like this: delta y, and then we will transpose the y there, it becomes minus y. And then for the x plus delta x can be expressed as x squared expansion binomial, and then 2 times x times delta x plus square of delta x, and then we can distribute the 4 by x plus delta x. So this is now 3x squared, distribute the 3x squared, 6x delta x, 3 delta x squared, and then distribute the 4, it becomes 4x plus 4 delta x plus 12. And then for the y, we can substitute the value of y as the given function, 3x squared plus 4x plus 12, and then since preceded by minus operation, so we have to change all the signs of the subtrahend, so it is now negative 3x squared, negative 4x, negative 12. And then the next thing to do is we have to simplify before we will proceed to step number 3. So we can simplify by just adding or combining all similar terms. As you can see here, we can multiply or we can combine 3x squared minus 3x squared, that will be 0. 4x and then minus 4x, that will be 0. 12 minus 12, that will be 0. So remaining here will be 6x delta x, 3 delta x squared plus 4 delta x. So this is now the simplified expression. And then the third step is we have to divide both sides by delta x. So we have to divide by delta x. This is now delta y divided by delta x, and then 6x delta x divided by delta x, we can cancel the delta x, so this is now 6x. And the next term, 3 delta x squared divided by delta x, so that will be 3 delta x plus 4 delta x divided by delta x, so we can cancel the delta x, this is now 4. And then for the last step, we have to evaluate the limit of delta y with respect to x as delta x approaches to 0, because this is already the derivative of the y with respect to x. So when delta x is 0, so we can now consider this as 0. So remaining here is 6x plus 4, which can be simplified by factoring the 2. So this is now the derivative of y with respect to x as 2 times the quantity of 3x plus 2.